Hello everyone and welcome back to my channel Code with GoldenCat. Today we'll create an expense tracker web application project using Spring Boot framework. By the end of this video, you should have a web application that looks like this and allows you to keep track of your expenses and their total amount. So if I add an expense here with the name waffle of 10 value and then save it, you can see I'm getting the total as 10. Now I can edit this, something else, say 20, and then the total changes as well. And I can also delete this. So without further ado, let's begin. First, let's download the skeleton project from our GitHub repository named Expense Tracker. Now, this repository has two branches, start and end branch. The start branch has the skeleton project or starting project with some HTML and CSS files to keep the focus on learning Spring Boot. And the end branch has the finished project, which you can use to compare your code and use if you get stuck at any step. Now you can also create this project from scratch by yourself, but we are using the skeleton project to keep the focus on learning Spring Boot only. For cloning this repository, we'll go to code, then copy this URL, then we go to our directory and then type in cmd here, then type in git clone and then the URL. This would clone the repository. And here we have the project expense tracker. Now if I open intellij, you can see right now I'm at start branch. So if I show you here, start branch doesn't have much files right now. Whereas if I switch to end branch by checking it out, you can see it has all the files that we'll be creating in this video. Now let's switch back to start branch. Now that we have the startup project ready, let's take a look at what we are getting in it. First, we have a Java file called expense tracker application, which acts as the starting point of the project. Now, this file has an annotation that is @Spring Boot application, which is a convenience annotation in Spring Boot that combines three commonly used annotations. @configuration, which marks the class as a source of bean definition for the application context. Then @enable auto configuration annotation, which enables Spring Boot's auto configuration mechanism, which automatically configures Spring application based on the dependencies on the class path. And finally, @component scan. This enables component scanning so that the web controller classes and other components you create will be automatically discovered and registered as beans in the Spring application context. If you didn't understand all the annotations explanation, then it's okay. You can ignore them for now. Just remember that @Spring Boot application marks the starting point of the project. Now, before we move any further, let's first understand what is a bean and dependency injection in Spring Boot. So we can take a real world example to understand these concepts. Imagine you own a coffee shop and you're managing the different components required to make a cup of coffee. The components include a coffee machine that brews the coffee, a milk steamer that steams milk for latte and cappuccino, and a coffee maker, which is a person who operates the machine to make different coffee drinks. In a Spring Boot application, you would define all of these components as beans. So, a bean in Spring Boot is simply an object that is managed by the Spring container. In other words, Spring takes care of creating instances of these objects, configuring them, and managing their life cycles. Now, coffee maker is also a bean, but it depends on coffee machine and milk steamer bean to make a latte. So Spring automatically injects the coffee machine and milk steamer beans into the coffee maker bean, and that is known as dependency injection. So formally, dependency injection in Spring Boot is a design pattern that allows objects to receive their dependencies from an external source rather than creating them internally. This promotes loose coupling, making the application easier to manage, test, and maintain. In Spring Boot, DI is typically achieved through annotation like @AutoAdd, which we'll see in a moment. This annotation enables the Spring container to handle the creation and injection of dependencies. Now that we understand the fundamentals of Spring Boot, let's continue our discussion about the startup project. So in this startup project, we have the static folder, and inside this, we have a CSS and images folder. Now this CSS file contains a bunch of custom CSS that we have defined for our views, and then we have this background image for our application. For the templates, we have this add expense HTML page, which is used to add expenses into our application. Then we have this index.html, that is the main page that shows the total expense and the list of all expenses that we have did for now, and the update expense. Now you can merge this update expense page with add expense if you want, but to keep it simple, I have kept them separated. Now this page is responsible for updating an expense. Now all of these templates are using Thymeleaf and simple Bootstrap, so I'll not go into much detail for them. Then in this application.properties file, we have defined a couple of properties for the database that we'll be using for this project. And the database that we'll be using is H2 database. So the H2 database is a lightweight open source relational database management system written in Java. It can be embedded in Java application or run in client server mode. It is very similar to any SQL database, so if you want to migrate this application to use any other relational database like MySQL or PostgreSQL, then you're free to do so. Then we have defined a couple of JPA properties here, which we'll use in a couple of moments. Then in the pom.xml file, we have defined a couple of dependencies here that we have been using so far. The only dependency that we have just used is this H2 database dependency. Now that we understand what we are getting back in our startup project, let's dive straight into coding. So first, let's close all of these files. And then we have to create a couple of folders here. The first folder would be controller. Then we'll have a service folder here. Then a model. Then a repository. Now for this project, we'll be using the MVC architecture. The MVC or Model View Controller architecture is a design pattern that separates an application into three interconnected components. Model that manages the application data and business logic. It directly handles the data, logic, and rules of the application. View represents the user interface and displays the data to the user. It does not contain any business logic. Controller, which acts as an intermediary between the model and the view, it handles user input processes using the model and returns the appropriate view as a response. So in our case, these templates that we have already created are a part of view. Now the basic workflow of MVC goes like this. The user interacts with the view, for example, clicks a button. The controller receives the request, processes it, and interacts with the model. The model updates or retrieves data as necessary. The controller updates the view with the new data, and the updated information is displayed to the user. Now first, we'll create a model here, and we'll name this model as expense. Click on add. Now this model would be by entity. Now we are marking this class as a JPA entity, meaning it will be mapped to a database table. By default, the table name will be the same as the class name, that is expense. But this can also be customized if you want. Once this done, we'll write @ID @generated value strategy equal to generation type dot identity private long ID. Now @ID indicates that this field is a primary key of the entity. The primary key uniquely identifies each record in the database table, and the generated value annotation specifies that the primary key value will be generated automatically by the database using auto increment in SQL database. Now after this, we'll define a few more columns here. Private string description, then private decimal amount. Now that it's done, we can define its getter and setter by clicking on generate and then click on getter setter and then copy all of them. And there you have it. Now that we have the model created, we'll move on creating a repository here. So we'll name this repository class as expense repository. Click on add, and this would be an interface. Now we'll mark this interface as @repository here. Now @repository marks this interface as a Spring Data repository. This annotation is optional but recommended as it provides additional functionalities such as exception translation, which converts database related exception into Spring's data access exception. Other than that, we'll also extend an interface here, extend JPA repository, and this would have expense and long as its parameter. Now, this JPA repository interface is a Spring Data JPA interface that provides CRUD, that is create, read, update, and delete operations, and more advanced querying capabilities out of the box. By extending JPA repository, expense repository inherits several methods that can be used to interact with the database. The first parameter in it, that is expense, is the type of entity that the repository will manage. And the second parameter, that is long, is the type of the entity's primary key. Now, by extending JPA repository, expense repository inherits many methods, including save, that saves an entity, find by ID, that finds an entity by its ID, find all, that finds all the entities, delete by ID, deletes an entity by its ID, and count, that counts the number of entities, and so on. Now, if you remember earlier, we have defined a way to connect our core Java application to a MySQL database, and that process required a lot of code. But with using Spring JPA, we can simplify the implementation of data access layer in Java application. It provides a repository abstraction over the JPA, making it easier to interact with relational database. So we don't have to manually insert SQL statements and queries here. Now we'll use this repository in our service class once we create that. So let's create it now. So in this, we'll create a service here called expense service, and we'll mark this class with an annotation @service. Now @service marks this class as a Spring service. This annotation is a specialization of the component annotation and is used to indicate that this class holds business logic. Spring will automatically detect and register it as a bean in the application context. After this, we'll use the dependency injection to get back the expense repository dependency. We can write expense repository here, and to use dependency injection with it, we'll simply write auto-wired. And that's it. Now we can write its method. The first method we'll type is public list expense get all expenses, then return expense repository dot find all, which would return all the expenses. We're getting back an error here. We can import this class now, and that resolves it. Once this is done, we'll add another method here, public void save expense, which will take expense as a parameter. And to save this, we'll simply type in expense repository dot save and then expense. Now this method saves or update an expense using the save method from expense repository. If the expense already exists based on its primary key, it will be updated. Otherwise, a new entry will be created. After this, we'll create yet another method, public expense get expense by ID, and then long ID. Now for this, we can write return expense repository dot find by ID, then ID dot or else will send back null. Now this method retrieves an expense by its ID using the find by ID method from expense repository. This returns an optional expense, and or else null is used to return null if the expense is not found. After this, we'll also create a method for deleting the expense. So we'll type in public void delete expense by ID, long ID, and then we can type in expense repository dot delete by ID, and then ID. Now all of these methods that we have written for expense repository will get translated to their respective SQL commands as shown here, and then they would be run against the H2 database. Finally, now we'll create a controller here with the name expense controller, and we'll mark this as controller. Now marking a class with @controller annotation marks this as a Spring MVC controller that would handle HTTP requests and return views. Now we'll again use dependency injection here. We'll type in autowired and use that to get expense service all set up. Now we'll write our first endpoint here, get mapping, that will take in single forward slash here as the path, then public string view homepage, model, then model. Then we'll create a list of expenses equal to expense service dot get all expenses. Then we'll take a big decimal object here, total amount, and we'll use Java Stream API to get back the total amount of all the expenses. So we'll type in map expense get amount dot reduce big decimal dot 0 comma big decimal add. Now that we have the total amount value, we can add that in the model by typing in model.add attribute expenses comma expenses and model.add attribute total amount, then total amount, and then return index.html as view. So if I open index.html here, you can see that we're using the expenses here to fill up these values expense.id, description, and amount and we are using the total amount value here. Now let's go back to expense controller here and create other methods as well. So the next method we'll be creating would be to show add expense page. For that, we can type in at the rate get mapping forward slash add expense, then public string show add expense page model, and then expense expense equal to new expense. Then we'll add this as add attribute expense comma expense, and we'll return add expense here. Now for saving that expense at that add expense page, we'll type in at the rate post call by typing in at the rate post mapping. We'll type in at the rate save expense, then public string save expense at the rate model attribute expense, then model. After this, we'll call expense service dot save expense method and save this expense. After that, we'll return a redirect to our home page. Now we'll also need to create an endpoint for showing our edit expense page. We'll type in at the get mapping edit expense slash id public string show update expense page at the rate path variable id long id comma model expense equal to new expense service dot get expense by id and id, then model dot add attribute and then we can return back the update expense view. And now we'll write update expense endpoint. We'll type in at that post mapping slash update expense slash id public string update expense at the rate path variable id long id comma at the rate model attribute expense We'll type in expense, existing expense equal to expense service dot get expense by ID, and existing expense dot get description expense dot get description existing expense dot set amount and expense service dot save expense. And then we'll also redirect it to our home page. And now finally, we'll write one last endpoint here for deleting. We'll type in get mapping delete expense slash ID public string delete expense at the rate path variable ID long ID, and then expense service dot delete, and then again redirect to our main page. And that's it. We are ready to build and run our project now. We'll go to terminal here and use this command mvn spring boot run. Now if I open Google Chrome here and type in, you can see we are getting back the home page. Now if I add an expense here, say coffee, which is of 10 bucks, and save it, so the total is 10 now. Now if I add another thing like a biscuit of 5 bucks and save it, you can see I'm getting back the total of these additions. Now I can also edit this. So if I change this to 20 and update it, you can see it changed the value here. And I can also delete it. So if I delete this, you can see that I'm getting back the total as 20 now. Now our application is working as expected, but before we end this video, I would also like to talk about how to access the H2 database. So you can access H2 database by duplicating this tab and then typing in / H2 console. Now this would ask you for username and password that we have already defined in our application in application.properties file. So if you go back here, you can see the username is SA and the password is password. Then the data source for our H2 database is this, and the driver name for using the H2 database is org.h2.driver. Now if I go back to Chrome and type in password here and then click on connect, you can see I have this table here, expense. If I run select query on it, it has 3 columns here, ID, amount, description, which matches to what we have defined in our model, that is this expense. So we are basically creating this table in our H2 database. Now if I add some expense here, like water, then at 100 here, save it, and now run this again, you can see it's getting added here as well. Now you can also use this to add data here, and we generally use H2 database for testing and prototyping an application, because if we stop this application and rerun it, then all of this data would be gone. So this is how you can create your own expense tracker application. As always, we'll end this video with a quote that says, "The more we value things outside our control, the less control we have." Thank you for watching and have a great day.